Good morning. Today we are on page 13 of your student journal, and our objective or our goal for today is today I will generate. Generate means to produce or to create, so we're going to generate equivalent fractions by multiplying by 1. Okay, so our goal or our objective is today I will generate equivalent fractions by multiplying by 1. So let's look at our vocab. Our first vocab word says multiplication property of 1. The product of any number multiplied by 1 is that number. This property is also known as the multiplicative identity property. And it's known as the identity property because when you multiply something by 1, it doesn't change its identity. It stays the same. So 6 times 1 is still 6. Now, we're going to be talking about fractions though, so we're going to talk about what fractions are equal to 1. So here they have 1 is equal when the numerator and the denominator are the same. That's why they both say A over A, or the example is 2 over 2. So anytime your numerator and your denominator are equal to, or the same, it means it's equal to 1. So we're going to kind of put some examples down here. So 1 could be 2 over 2, but it could also be 3 over 3, it could be 4 over 4, it could be 5 over 5, 6 over 6, it could be 12 over 12, and we could even jump to 100 over 100. So anytime the numerator and the denominator are the same, that means that it's equal to 1. Okay. Here it explains to us how we're creating equivalent fractions. And equivalent just means equal, obviously. So 3 over 4 times 1 is 3/4. But if I multiply 3/4 times 2 over 2, that still is equal to 1. So the value doesn't change, it just looks different. Okay, so that's what this lesson is going to be, is we're going to be creating these or generating these equivalent fractions by multiplying by 1. We're also going to be proving our answer using some models. Okay, so I'm going to get started on my first one. Now I put down my green pen, which means you can set down your pencil, and I'm going to grab my red pen, which means you're just going to watch with me right now. So my first problem says 3/4, and they want me to create or generate an equivalent fraction. So 3/4, I can choose what I want to multiply this by. Now, since I don't want to change its identity or value, I can only multiply it by something that's equivalent to 1. So I can multiply it by 2 over 2, and that shouldn't change its value at all. So 3 times 2 is 6, and 4 times 2 is 8, which means 3/4 is equivalent or equal to 6/8. Now I can show that to you and prove that to you on my number line this way. So if this was my first number line, and I had 0 and 1 to 1, and I want to divide this into fourths for 3/4. 3/4 means I have 1, 2, and 3 of the 4 pieces. That's what 3/4 means, because this would be 1/4, 2/4, 3/4, and 4/4. So here is my number line. Now if I took a number line very similar and I created the same intervals, but then I decided I'm going to cut each one in half one more time, Let's see what I cut it into. 1, 2, 3, 4, 5, 6, 7, 8 pieces. So this time I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. So 3/4 is exactly the same as having 6/8 on a number line. Those two are equivalent. So in both, I have the same amount. I've just cut this one or partitioned this into more sections than this one. But they both have the same value. Okay, let's look at another one. This one says 2/3. So again, I can generate or create an equivalent fraction by multiplying it by a fraction equal to 1. Now, I have to make sure my fraction's equal to 1 so I don't change its identity. So for this one, maybe I'll multiply it by 3/3. So my equivalent fraction would be 2 times 3 is 6, and 3 times 3 is 9. So 2/3 is equivalent to 6/9. And I can prove that to you by here, I'm going to make 2/3, and I'm going to shade in 2/3 for you, show you what that looks like. So I have 2/3 there, but here I'm going to partition my whole into ninths. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And look what I have. 1, 2, 3, 4, 5, 6/9 is worth the same amount. So look how they line up. They're both worth the same amount on my model. Okay, so let's try some of these together. I'm going to grab my green pen, which means you're going to join me, and let's work on page 14 together. So on page 14, we're on number 1, and it says 1/6. So we want to find or generate an equivalent fraction using the multiplication property of 1. So we can't change its identity or its value, so we have to multiply by a fraction equivalent to 1. So let's just multiply it by 2/2. And what do we get? We get 2/12. So 1/6 is equal to 2/12. They're equivalent fractions. And we can show this on our number line. It's just going to be a little bit harder because those are larger numbers. So we have 0 and 1. So to show what 1/6 looks like, we need to divide this number line into 6 equal parts, or partition it. So 1, 2, 3, 4, 5, 6, and we have 1/6 of them. That's what 1/6 looks like. Now on this one, if we were also to divide it into 6, I just used my same lines, but I want to cut it into 12ths now. That means I would have to partition each one again. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. And if I look at what does 2 of the 12 parts look like, it looks like the same amount as 1/6. So those are what we'd call equivalent fractions. They're worth the same amount. Okay, let's try another one. This one says 2/5. So we could use any fraction. We could multiply it by 5/5 or 10/10 or 3/3. But since we're going to have to prove it using our models, we're probably just going to want to stick with something easy like 2/2. So we're going to multiply 2/5 by 2/2, which is equal to 1, and we get 4/10. Now, if we didn't have to prove this, we could have done something else, and we could have multiplied it by anything. We could have multiplied it by 6/6, which would have given us 12/30. So what that tells us is that means that 2/5 is equal to 4/10, and they're both equal to 12/30. Now, because we have to prove it on our model though, we're going to want to use our smaller digits. So 2/5, the denominator 5 means we have to partition our whole into 1, 2, 3, 4, 5 pieces. And the 2 means we have 2 of them. Okay, so I'm going to just use those same interval lines to help me. But then because I want to partition this into tenths, let's cut or partition each of those in a half. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which my denominator is 10, and I have 4 of them. So 4/10 is equal to the same as 2/5. They're the same value, they just are written differently. Okay, so ladies and gentlemen, you're going to be trying some of these on your own, and you're also going to be asked to prove it using models or number lines. Have a good afternoon. Bye-bye.